Yeah, hello everyone. I'm Oli, and welcome to this stream with Josh Tobin, Alexei Krabrov, and me talking about building LLM-powered applications in production. So first, I want to give you a little bit of introduction why we gathered together here. Um, in just 2 weeks, we're gonna start our wonderful Scale by the Bay conference. It's independent conference in San Francisco Bay Area, and we are in our 10th year, and this is really wonderful, especially given that we had a very big break between now and the last edition in person in 2019. And we always have a wonderful first day of top notch workshop. And this year, we're happy to have Josh with us. But before we go um, into details, I want to tell you that you should register, and we can post the code for you, which will give you 20% off on the workshop. And yeah, welcome. Everyone, let's introduce ourselves.
Hey, I'm Josh Tobin, co-founder and CEO of Gantry, and one of the creators of the full stack courses. Most recently, focused on LLMs, but also AI more broadly.
And my name is Alexei Krabrov. I'm the founder of Scale by the Bay, which happened first time 10 years ago, as Oli said. And Oli ran the online versions, so we did not have a complete gap. We kept it afloat, kept it alive. Oli, as you can see, does a fantastic job online. I'm also director of open source science at IBM, where I connect open source developers and researchers so we can solve hard problems of humanity, like climate change, making new drugs to cure diseases, carbon capture, and so forth. And also, I've been recently elected chair of Generative AI Commons at Linux Foundation. So I'm in different angles, here, and super happy to have Josh with us and talk about generative AI for developers.
This is my turn. Yeah, I already kind of said so many words about myself. Yeah, so I'm helping Alexei with Scale by the Bay ever since COVID hit, and we had to go online. So we had a couple editions there, and now I'm excited to help organizing Scale by the Bay again. And also, I'm leading DevRel at Bytewax. This is a Python streaming processor. So that's real-time data engineering and all of that, including Python, is my area of interest, which we'll have a lot to talk about at Scale by the Bay. But not only, the hottest topic right now is LLM, of course, and AI. So kind of start our live stream. I want to ask Josh that, like, first I want to say that I think FSL, full stack deep learning, was kind of the first workshop that covers all the aspects of how to build the like production ready, like how to look at all aspects of building things, do that hands on, and what it was like to pioneer this. Like, what did you keep in mind when building this course?
Yeah, I mean, really, it just came from our own personal experiences and a lot of the pain that we went through in building applications with AI ourselves, and the inspiration was just to help people, maybe take a shortcut through some of the learnings that we had to go through the hard way, and yeah, hopefully, it's been able to do that for a lot of people.
Let me dig a little bit more into this, Josh. So, I've not caught the first courses by FSDL, but I found the LLM bootcamp, which was held in the spring, right? And I immediately registered, and I knew I had to jump on it because it was sold out completely, right? And so when I went to this South San Francisco conference center where it was held, I found that, in interesting kind of contrast to a lot of the area events, majority of people were from all around the world, right? And they came from different places, and a lot of them were like young data scientists, developers who wanted to change their career, right? Like they basically almost gather their savings and bought the lottery ticket, right? They went to San Francisco to take this course to learn from you guys. So maybe you can tell us like what makes this topic so important. And you were like early pioneers teaching this, right? And you put together, I think, really the best course of a compressed version of which we're going to see and updated in our training. So what makes this so effective? Why do people come across the oceans and kind of in your questions and interactions with the participants? What like what's your thinking? Why people jumping on this not right now?
Yeah, I think we bring a different perspective as organizers of a course. I think for a lot of courses, they're really focused on teaching fundamentals, like teaching the core material that you need to know in order to understand a subject. And I think that's really important to learn. But the perspective from our class has always been like, well, what do we wish that we knew? What are the things that the normal course that you take doesn't really teach you that you'll learn on the job the hard way when you actually go start trying to apply some of the lessons that you learned in your initial course. And so it's just by virtue of our experience, it's very pragmatic and it's very grounded in like things that you actually see in the real world when you're trying to build applications. And I think that's why people tend to enjoy it, and it does often end up being a jumping off point for folks switching careers and getting into AI. We've like over the years we've been lucky enough to have like a number of success stories of that, where folks came to the boot camp because they wanted to become an AI engineer or ML engineer, and now are like really amazing kind of standouts in the field.
That's great. That's great. Yeah, and I've seen this firsthand, right? And it was like super exciting. So tell us a little bit, how this course is tailored to developers, and kind of maybe talk a little bit about different aspects of, interacting with LLMs. A lot of folks try to, play with ChatGPT and probably have fun doing this, right? But what makes it different to do something in the real world? What does it mean to develop applications of LLMs? Who are these LLM developers that we need to make to live in this new world?
Yeah, it's pretty interesting. I mean, I think the who question is changing very fast, and in a lot of ways, we had a front row seat to that since our class was always focused on production. But in the traditional pre LLM world, a lot of these AI apps were being built by large teams of highly trained AI specialists, right? Like folks with PhDs, software engineers who had really gone deep in this part of the field for more or less their whole careers. And that's because building models was really hard and very specialized. Now you can just, as I'm sure many of you have, you can just go and call an API and get access to a model that is way better than your team of 100 engineers could have built 5 years ago, and it just works off the shelf. At least it just works initially. So the who is changing very quickly, and I think what we've seen is that a lot of the teams that are building successful products with AI are not really AI teams anymore. They're they look more like sort of traditional product engineering teams that are thinking about things a lot more from the perspective of like, hey, how do we test this thing, get it out in front of users quickly, learn what they really need, and start with something that's very simple before we add a lot of complexity. Oftentimes after those teams hit success, then they'll start to bring in folks that look more like traditional machine learning engineers to help scale up or reduce costs, or really squeeze the last couple of percentage points of performance. The interesting thing though is that like even though the barrier to entry to creating these applications is lower than it ever has been, the process of like going from an app that works, like technically works, like you can put it in front of someone and they'll be able to use it, and actually having a really high quality product that creates the outcomes that you want to create for the users of the product, that gap is as big as it's ever been. So it's easier than ever to get started, but it's just as hard as it's ever been to like go from the first version to the thing that actually works really well. And one thing that I've noticed, and being in this field for a while, is that like, the way that like the really great AI teams approach building applications with AI, like the way that the folks at OpenAI think about this, the folks at Tesla think about this, is like very, very different than the way that your team probably thinks about it, right? Like for a lot of the teams that I talk to, they are just really kind of concentrating on getting the first version of the app out there. Like they see that as kind of the goal. It's like, how do we make this thing good enough that we can ship it? Um, if you look at like how ChatGPT was developed, OpenAI took a very different approach than that, right? Like they launched something very early. They launched, GPT-3 year and a half before ChatGPT came out with not a ton of real traction. Not nothing, but not an enormous amount. But that entire time, what they were doing is they were like gathering data, they're understanding use cases, they were capturing human feedback, and just rapidly iterating on that model over and over and over again, um, fixing the pain points that people had with it until it got to the point where it was this like sort of overnight success, right? And so that's I think the big difference between like how great AI teams operate and how most AI teams operate is like this focus on on iterating beyond the first version. How do you go from like something that's good enough to something that's really good? That's where a lot of the magic lies in building AI powered products these days. And so that's a lot of the mindset that we and the tools that we hope to teach in the class.
Thing is that, yeah, I noticed, I think we hosted you at the Air AI before you went, out of stealth, and then I checked your website recently. It really looks, it's like a archetypal Silicon Valley startup website. You have clear explanation of products, you have main points, and you have use cases, and you have customer logos, and you have testimonials from them. So I wonder what's kind of your most interesting feedback from these customers, right, that are using it already.
Yeah, I think there's been a lot of interesting learnings. I think one of the big things has been just how early a lot of folks are in this journey of like going from an initial version to a great product. And I think we saw this massive wave of LLM powered products get released in the beginning part of this year. Um, it just felt like a new product was being released every week from big companies, even that aren't you typically don't expect to move as fast as they moved here. I think it's easy to draw the wrong conclusion from that and think, hey, we're almost there, right? Like everything is going to be AI powered overnight. The reality is that I think what's happening with a lot of these products is they hit some initial success early on because everyone was excited about AI and wanted to try all these new AI powered features. But I think what we're starting to see is like kind of an initial wave of churn for those first generation of AI powered products because people start to realize like, hey, the limitations that this thing has, I'm not actually sure this is saving me time or making my life easier to use this. Um, so a lot of these products seem to be plateauing, and I think that's kind of like a natural part of the development of this technology is like people need to figure out how to use it beyond just the use case of like slapping chat out into something and expecting all of your users to go crazy for it. You need to start thinking about like, how does this actually solve a user problem? And how do we get it good enough that it solves the problem consistently enough that users are willing to change their behavior and pay us money to use it.
I love this, focus on kind of the detail, also the crucial kind of last mile to make product really useful. It reminds me, so Oli is coming to us from the beautiful Seattle, and I used to live in Seattle, and I had a lot of friends in Microsoft, right? And Microsoft is cool now. It used not to be a school, before it got GitHub and became all open source friendly. But a good friend of mine was the manager there, and he told me that what Microsoft mastered really well is basically making sure this weird kind of 5%, the hardest of making software really work, done, right? Because you need to open all possible menus in Microsoft Word and click on them in random order to make sure it doesn't crash, right? And somebody has to make sure that any possible combination of product features which a user can invoke will still make sense. And so that kind of brings me to this kind of developer focus. So you talk about, for instance, test-driven development of LLMs. And maybe, for those of us who are developers, we know this is, very important part. But, that's one topic I think a lot of folks who are no developers, maybe, coming in from humanities and philosophy and rhetoric and law and whatever, like domain users are coming in. Maybe you could tell us a little bit what is test-driven development? Why is this an important tool in the arsenal of developers?
Yeah, I don't think developer centric is exactly the right framing because when I think of developer centric, I think of like developer tools, like tools for folks that are that are aimed to make your productivity as someone writing software better.
Mhm.
But what we're really focused on here is like product focused, um, which means like how do we shift the conversation from like just making some version of the LLM powered app work no matter what, or making this thing good enough, or like gluing all the pieces together, or training the best possible model. How can we take all those mindsets and instead focus them on outcomes for your users, which is really, if you're building a product, the thing that you should care about. And so developers play a critical role in that, but I think their developers are just part of the product team that develops these features. And so I think a lot of what we teach, I mean, maybe some of the tactical details are less relevant if you're a product manager or something like that. But I think most of the mindsets and like ways of approaching these problems that we teach are relevant, even if you're in a different role than software engineer. And if the like expectation I think you should have is not so much like we will make you more productive in like day-to-day work, but I think we probably will, but it's really more focused on like how do we make the work that you do matter more, by focusing on the right problems, and solving them efficiently. And to answer your question, like one of the big things that we advocate for is this philosophy of sort of test-driven development for AI applications, or LLM-powered applications in particular. And if you're a software engineer, you're familiar with this term already. And what it means is that rather than writing like your software and then thinking of testing as an afterthought to the software, instead you treat testing as like a really central part of your development process. So at every stage of development, you think about like, okay, for this feature I'm developing, this line of code that I'm writing right now, what are the 3 or 4 things that I could do to test this, so that you build up this library of tests over time as you develop, rather than needing to treat it as an afterthought, which almost always leads to low coverage of tests relative to the code that you've written. In the AI world, there's like a similar concept, which places testing or evaluation at the center. It works a little bit differently because AI development works differently. But the core idea is that like rather than just kind of building your like writing your prompt, or like building your chain of models, and then just kind of uh, playing around with it to see where it works or doesn't work, which is a totally valid way of doing things. Instead, we try to place a more rigorous emphasis on measurement and evaluation at each stage of the development process. So we try to help you focus on like how do we develop the best understanding that we can of whether the system is doing what it's supposed to be doing, even as we develop it, and then iterate on that measurement harness that you've built as you start to roll the product out to more users, um, and or even like internal testing. So you build this test suite of like cases that you want the model to perform well on. You can think of these as like example inputs or example conversations that that this model needs to be able to handle. You build that up incrementally over time, and you set things up so that you can run it automatically. So that every time you make a change to your prompt, or a change to your model or whatever, rather than just needing to do a bunch of guess and check, or vibes based measurement to tell whether this thing is actually doing what it's supposed to be doing, instead you should get some numbers that tell you, at least directionally, whether this is moving in the right direction. And over time, as you continue to develop, you should build more and more confidence in those numbers, as you continue to build out the set of examples that you're running the evaluation on, and the ways that you quantify performance on those examples.
Okay, so as a software engineer, I actually love test-driven development, and I follow this paradigm and everything. But at the beginning, you mentioned the difference between the mindset in bigger companies and smaller companies. So how do you think about your product? When do you create like prototypes or something and post that? So the question is, if I don't know if I'm gonna throw away my prototype or something, um, is it still does it still make sense for me to spend time on TDD? And if so, why?
Maybe not in the context of software development, but in the context of LLMs, I think definitely, because it saves you time almost from the beginning. So for me, like, I won't like I'll typically start by writing a prompt. If I'm like playing around with an idea or something, I'll typically start in ChatGPT or OpenAI Playground, some sort of UI based thing like that, just to get an overall feel for whether things whether this thing I'm trying to do is feasible at all. But then I'll pretty much immediately move into gantry after that. And the reason for that is because I want to, like, in order to know whether the prompt that I'm writing works, I need to see if it works on more than one example. And so immediately just like being able to run your prompt on like multiple inputs at once is super valuable. And then naturally, as part of doing that, you start to develop opinions on what are good or bad outputs. As you develop those opinions, you can encode those into evaluation criteria, into quantitative metrics to measure performance. And so pretty much like maybe not from like minute zero of the project, but from as soon as you start to like make more than a handful of changes to your prompt, this type of methodology will immediately save you time. And so more than a philosophical consideration, it's like a practical one that I think you can go faster if you're able to see multiple outputs at the same time. And then if you're looking at multiple outputs at the same time, you can go faster if you don't have to read all of them in detail every single time. You can have a model read them for you.
Alexei, we can't hear you.
Let's shift gears a little bit. So I think everybody saw the news. The White House published the executive order on AI safety, and I think Gantry is squarely in the space that helps developers evaluate this. So I wonder, Josh, what do you think of this news and how Gantry can rise up and be helpful in fulfilling the requirements?
Yeah, I haven't had a chance to read it yet, so I don't really want to comment on it until I've looked at it myself. But I think it just came out this morning. So
I can tell you the gist. The gist is basically saying, right, like any large company developing, foundation models must share the applications with the US government. It should test, or share red team test results, and evaluate. Basically, AI safety should be evaluated now more formally, more often, and the results should be shared. Right, and so what I think, for your set of tools is actually helps one do that, right?
Yeah, for sure. I mean, I think like without sharing an opinion on, one way to think about evaluations is they're like a contract between the developers of the AI-powered application, whether that application is a foundation model or whether it's a downstream application. It's a contract between the developers of that application and the consumers of that application. Or other stakeholders in the development process. So in the context of a lot of our customers, the evaluation is a contract between whoever's writing the prompts and other people who care about model performance, other people who, and in some ways between the developers of the prompt and the end users themselves. Because what you're saying when you write an evaluation is you're saying, okay, this is the guarantee that I make about what my model is going to do successfully. And so the more complete that evaluation is, the more representative that evaluation is of the tasks that you care about in the real world, the stronger that contract is. And so I think like from if taking as an assumption that we think it's a good idea for regulators to regulate the performance of foundation model providers, which I think we could debate that one too. I think evaluations are a really good way to do that. And I would say probably the evaluations that folks should be looking at are not just at the level of foundation model providers, it's also at the level of application developers.
Yeah, I mean, obviously, I think the order is framed in the wording like develop guidelines for evaluations, right? And so forth. Obviously, we don't yet know, the full technology. So I think it's kind of laying down the framework. But I think in that sense, what I was really surprised, I opened Twitter this morning and I found a lot of tooling companies are tweeting their support for this, right? Because I think the first line of defense will be the right set of tools, right? And I think kind of regardless of, whether it's a good or bad idea for the governments to regulate technology, first of all, there is now a requirement, right? And then secondly, the tooling, I think, makes sense really independently, right, of this. I think, like in my mind, so, generative AI commerce is the new committee of Linux Foundation, which we started. And I think one of the questions we want to ask, and everybody's asking, how do you evaluate LLMs, right? And so in that sense, I actually wanted to kind of to poke a little bit deeper technically. So when you say, it's really intriguing on Gantry website, you basically say, instead of like manually rechecking your prompts every time something changes, run programs, right? And so this is, as a developer, it sounds like music to my ears, right? But what bothers me in this whole context, it feels like Sam, like I have this constant feeling that, you can write a better of prompts, which are just fragile and brittle questions, and you add one word there, right? You say like, tell me about noises of penguins in Antarctica, or you can say, tell me about noises penguins in Antarctica make with drums, right? And then of course the thing will say, I don't know about drums. So maybe it suddenly may say, I shall ask this question. To say, yeah, penguins can make music by flapping their wings against the ice, right? So the thing will start making interesting kind of derivations. And so what I wonder about, right, since like a single word of a prompt can change dramatically the output of a model, right? And the word may not be obvious to human, that kind of will cause cascading change. And you say that you can write programs instead of checking words. Can you elaborate a little bit? How can we kind of assuage this fear of the sudden hallucinations popping up in a normal working flow, which you think is under control?
Yeah. Well, first of all, I just have to say, I think you should always be skeptical of companies expressing support for things that directly benefit them. So, if you hear tooling providers in support of AI regulation, just probably always have that in the back of your mind. But to answer your question, I mean, the way to think about it is like, so let me unpack the question into a couple of different components, right? So the first component is, how do you know that you can trust your measurement? So suppose that I have a comprehensive set of inputs that I know that I want my model to perform well on. How do you, and let's suppose that the output of the model is qualitative, like it's a paragraph of text or it's something that's difficult to quantify performance. Then if you're using another AI system to quantify performance on those subjective outputs, how do you know whether you can trust how do you know who's watching the watchman, right? Like, how do you know that you can trust the subjective evaluator? So I think the answer to that question is like, you shouldn't fully trust the subjective evaluator. You should think of automatic evaluations not as like the final say in model performance, but as a way to reduce the amount of time that it takes to run those evaluations, and to run evaluations at larger scale in a more cost-effective and efficient way. So I do not advocate for companies to remove all manual review of model outputs as part of their review process. And I don't think that anyone will, maybe some tool providers, but other than that, I don't think that anyone would advocate for that. But it is extremely helpful if you're developing a system like this to not have to, pay hundreds of dollars to your really expensive annotation team and, take up 2 or 3 days every single time you want to tweak one word of the prompt. And as a company, it's really helpful to be able to test your model on a much wider range of inputs for the same cost as testing it on, the 100 or 1,000 inputs that you're testing them on today. That's because the second part of your question is like, how do we know whether, if the model performs well on these inputs, and we trust that measurement of its performance, how do we know that it will generalize to other inputs? Like, just because it doesn't hallucinate on our evaluation set, how do we know that it won't evaluate on other inputs? And the answer is we don't really know that either. There's no guarantees that the model will do well, that just because the model did well on your data, it'll do well on other data. But what we do know is that in general in machine learning, you can have statistical guarantees when the data that you're looking at, that you're measuring the model on in production, is similar to the data that you measure it on offline. And so the way to think about the answer to that question is, no evaluation is complete without like a corresponding kind of online measurement of performance. And so what you want to look for is like, do the data points that we're looking at in production, are those similar to our evaluation set, or are there a lot of data points that we're seeing in production that are highly different from what we looked at when we did our offline evaluation? Because if that's the case, then that means you probably don't have enough coverage with your evaluation set to really be able to trust the results that you get there.
This makes a lot of sense. And I think you kind of hint at this future and this setup where basically you have a human in the loop, right, as a crucial part, because you basically are saying that, it's not possible to automatically trust this, neither the models nor the evaluators, right? Because then it will be a chain of evaluators. So at some point you plug in the human in the loop, and it sounds like your setup basically is that human in the loop empowered, right, with a set of tools.
Yeah, exactly. I think we think of it as like human verified auto evaluators.
Mm-hmm.
Like you should have people that are verifying that the auto evaluators do what you want them to do for your use case. I would also say though, like one nuance to add there is that evaluation is an easier problem than generation, and it's a more constrained problem, right? So like GPT-4 has to be able to solve any task that you want to solve. An evaluator only has to solve one set, like a smaller set of tasks, which is evaluating model outputs. And so it's possible to create it's possible for that your evaluation model could be more reliable than your generation model, just because the task it's trying to do is easier.
Interesting. And then, so in some way, right, when we talk about the future, we talk about basically new kind of human workers who will be humans in the loop, right? And they will use AI tools at their disposal. But a lot of problems will be ultimately human. For instance, like legal problems, right? Like if you're a judge, an AI can recommend you different things to do, but you have to make a decision. Similarly, healthcare, right? Probably you will always have to have a human doctor, at least in the foreseeable future, review any recommendation. And so in some interesting way, it sounds to me like you're building this worker of tomorrow today, right? Like your operator of gantry right now will be the human in the loop who will basically have these tools at their disposal. Am I right?
Yeah, I think that's the core idea in the longer term, right? Like we see, when we started working on this, when I started working in this field, the key person in developing AI systems was the AI researcher, or the ML engineer, right? Like this highly trained, highly specialized person whose job it is to build data sets, train models, and host them, and like run them at scale. In the future, I think the core person, and like starting to happen today, the core person in building AI systems is like think of it as like an AI operator, right? And this person is neither a machine learning researcher nor a software engineer, right? It's someone whose job it is to really deeply understand the problem and understand the data, and who has a good enough understanding of AI that they're able to guide the process of tailoring the model for the specific task it's designed to do. And in the future, like we want our software to be the software that the AI operator uses to do their job, to basically work with the model collaboratively to solve the tasks that they're trying to solve.
That sounds great. So maybe in the last part of our live stream, let's kind of mention some of the points why folks should come and take this training, right? And maybe I also want to say a few words about the context in which you have this, right? So Oli mentioned already, right, that this is the first day of this of our conference. So Scale by the Bay runs for 10 years in the Bay Area, and it alternated between San Francisco and Oakland, and now have this amazing home, which is an old Masonic temple on the shore of Lake Merritt, which is this, it's the opposite of the hotel atmosphere. It's an amazing historical and communal atmosphere, right? And we have basically community is a huge part of this. And the conference is basically oriented towards developers and data scientists and executives and VCs and founders, but all of them are united with very deep technical knowledge, right? So we have very simple litmus test. We ask people to put some code on a slide or really do a deep technology dive in each of our talks, right? And so that really sets a very simple bar that folks are really welcome to talk and do product marketing and and talk about their startups, given that they share very interesting technical knowledge that everybody else can use, right? And so what happens is, for 10 years doing this, we've found that this really works with the technical audiences. So the training we do the first day, we always do a bespoke training. And I can give an example. in 2015 was the first conference which pioneered the concept of data pipelines. Data pipelines not always was an idiom, right? So at some point it was Kafka, Spark, Mesos, Cassandra, and folks talked about this whole distributed systems as separate. So we put them together in a SMAC stack, which is the term we coined, and a lot of other folks picked up after that. It started at Scale by the Bay. Then we did the first official Istio training with the mesh, right? So when meshes became a thing, and so all of these things continue. So really, what we're really proud of doing this year with Josh and FSDL and these topics, we really, we want to bring this focus, right? The focus on developer and kind of in Josh words, right? Developers now has a new meaning, right? When I say developer for LLMs, it does not mean you were a Rust developer and suddenly you are an LLM developer. Probably will happen, maybe not, right? That's a good question. I heard that lawyers make excellent LLM developers, sometimes better than software engineers because they interrogate the LLM ruthlessly, right? And make it clarify itself. So, really what's exciting to me, right, as the founder, is then, we have this really fitting angle, right? And like we looked far and wide. There is a lot of various folks doing training, and we want to also kind of bring different kind of training, but we're starting with developer-centric in the sense of LLM, right? And so I just want to kind of just to reiterate why, if you're a developer, you don't want to miss it. Why should you come on Monday, November 13th, and spend the whole day with us and fellow developers learning about LLMs?
Yeah, I think if you want to learn how to build a prototype of an LLM-powered application, you can just go and look online and find that anywhere. You've probably done that already. You probably built a LangChain application or something like that. But there's not really a lot of good places to come and talk about how to make the leap from prototype to production, and that's really what this class is all about.
That's awesome. I think that's really going a full circle for me. Oli, do you have any?
So FSDL posted a lot of helpful material for the previous courses and everything. Can you tell people why coming in person is like what's the benefit of coming in person?
Yeah, everyone's different. I mean, you might find that you learn stuff really well just by reading through it online. A lot of folks find that if you have like a forcing function to listen to the materials and really engage with them, it's really valuable. Second reason is, we've found like over the years that oftentimes folks get value out of our content, but they end up getting a lot more value out of the connections that they make down the line, because you'll be part of, surrounded by a group of folks that are all interested in sort of engaging with the same field that you are. And then finally, we always do the most like latest and greatest up-to-date version of the content when we do live courses, which in a field as fast-moving as this means that there will be some differences with what you'll see online.
I actually want to add something because I attended this bootcamp, right? So in my view, like exactly like Oli said, right? You Google LLMs, trainings, bootcamps, examples, you got 3 million results. First of all, you don't know where to start. And even if you do know where to start, it's always lingering question, am I doing the right thing? Am I looking at the right thing? What do other people do, right? And so as humans, we tend to establish consensus when we gather in certain numbers, right? More than 10, right? And usually what I found personally, that's why people come to conferences. Again, you can look at it for all online. And by the way, if you want to look at it all online, you can spend the whole year. So, one of the points of doing it in person in the room is that you're actually going through much higher density, right? Because you're not distracted. You feel like you made an effort. You came here. Maybe you bought the ticket. Your company bought the ticket. You have to be here. You want to be here. You need to be here, right? Like it's a very different mode, being distracted by devices. But also, right, with other folks, you very quickly can check the pulse. So, for instance, when I was at the LLM Bootcamp, I hear the questions people ask, right? And I have an idea, right? And like sometimes people want to clarify, and you see what is the hard problem for others, maybe not for you, maybe for somebody else, maybe it's you're sharing this difficulty with everybody else. So I think, especially with a fast-moving area such as LLMs, I realized kind of getting together, Figuring it out is the fundamental human feature. This is how we establish truth. That's why, for instance, we have generative AI Commons at Linux Foundation, because we need to gather together and establish what are the standards of openness, right? What are the kind of features of open source we need to bring to bear on this, and why others, form other consortia, like how do we advocate before governments for AI, right? What do we do in the EU, and so forth. So, like in my mind, the training like this is the best to be in person, right? And again, we have a fantastic and beautiful venue where hallway track is always happening during coffee breaks, during breakfast, right? You're making friends, you're making connections, you're getting jobs, you're hiring people for jobs, you're raising capital, whatever it is you do in Silicon Valley, you can do here, right? So, and you absolutely have to check it out. So I hope, you guys have some idea now of this training, and we're everywhere on social media, and we hope to see you in 2 weeks.
Hope to see you there.
Yeah. Thank you, everyone, for coming and watching. Scale.bythebay.io/register and use the code we posted here, live20, to get 20% discount. And everyone probably can hear my daughter crying on the background.
That's a perfect view.
Yeah,
Well,
she says we should wrap up the live stream.
all right,
All
guys.
right, thank you.
We'll
Bye.
see